going to take a look at basic properties of sets. So a set is, let's just define a set first of all. Set is a collection of objects such as bands you saw at a concert. So a set is a collection of objects such as bands you saw at a concert. And then within that set, you have elements that make up the set. So this whole first section here is basic properties of set, is looking at how do we read a set, how do we understand what the elements that make up a set, what makes up a set, how do we define a set, and all of that basic information about sets. I'm going to change the thickness of my pen here. Then, like I said, the elements are what make up the set. So that's members of the set. So the elements are the members of the set. And when we have a set, we need it to be well defined. Well defined. And the definition of well defined is that the contents of the set can be clearly defined. Or clearly determined, I'll say. Meaning, if I were to say something like the set of all of my favorite bands, that's not well defined because that could change. Like I could like a band one year, then the next year I might not like it, or someone else could have a different set of favorite bands. So the has to be well defined. So writing a set, there's a couple different ways that we can write a set. The first way is roster listing method. Write a set consisting of 3 months. So if I'm gonna just use a listing method, this is the roster method. The roster method is saying A is equal to, and then these are, I'm really bad at making these, like, it's like the braces, I think they're called. That was actually pretty good. So these braces, so we write a set within the braces in this roster method. So write a set consisting of 3 months. So it could be April, it could be May, it could be October. And there's obviously a couple different versions of a set of 3 months, but that's just an example using the roster method. Write a set consisting of 4 days of the week. So let's call the set B using the roster method. So 4 days of the week could be Friday, Monday, Tuesday, and Saturday. There is a set, I'm really bad at making those braces, a set consisting of 4 days of the week. Write a set consisting of 3 states. So let's call it set C, and let's just write down 3 states. So I'll say Illinois, New York, and Michigan. There is a set consisting of 3 states. Now, the first example, using the roster method, the set of birds that are also mammals. There are no birds that are also mammals. So there is no set there, so this is called the empty set. Another way to notate the empty set is your braces, but with nothing inside the braces. So just an empty set. So the braces are not holding any sort of values in it. So that's just the empty set. Let me try one more time with those braces. I feel like, see that one was bad. Set builder notation. So set builder notation, the set is going to be the same. It's just a different way to notate a set. In the set builder notation, so let's use I'll use the concert example. So let's say B is equal to the set of all X's such that X is a band I saw at a concert. So that would be set builder notation. So let B be the set of all x's such that, so let B be the set of all x's such that x is a band that I saw at a concert. Set builder notation probably used more often in some classes. Set builder notation is used a lot. Roster method is very useful though for just listing out all the possibilities. On the set of all car makers, so let's say C is equal to the set of all x values such that x is a car maker. The natural counting numbers, so let's call that n, is equal to the set of x values such that x is a natural number. I want to do this one also with the roster method because the set of types of numbers, like counting numbers, natural numbers, integers, rational numbers, those are really common sets that you want to make sure you know how to read both the set builder notation and the roster method. So looking at the roster method here, roster method is the natural numbers. I know I'm getting close to my camera here. I'm going to go up here. But the natural numbers in the roster method, natural numbers start at 1. So it'd be 1, 2, 3, 4, 5, 6, and those numbers just keep on going. So that set is not going to end. So I have to indicate that by that comma, dot, 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 meaning that set is going to keep going on forever because the natural numbers are just the counting numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way through infinity. It just keeps on going and going and going. So we can't actually define the stopping point of that set. So that keeps going. Next piece of notation, element and not an element of. So the element symbol is almost like an E. So this is the element symbol. And then not an element of would be that element symbol, but with a slash through it. So not an element of. And that's just used for identifying if this element is in a set or not. So for example, let's say the band tool is an element in the set of bands. Tool's a band, tool's in the set of bands. Let's do an example of not an element of. The number 5 is not an element of the set of numbers 2, 4, 6, 8, 10, and that's just going to go. So even natural numbers. 5 is not in the set because 2, 4, 6, 5 would be right here between 4 and 6, but it's not. So 5 is not in this set of even values. So that's why we have not an element of that symbol, not an element. True or false? Number 9. Try to keep this on the screen. Nashville is an element of the set of cities in Tennessee. Yes, Nashville is a city in Tennessee, so that's true. Batman is an element of the Avengers. This is not a crossover, so no, that's false. Batman is not in the Avengers. He's in the Justice League. So that is a false statement. So that would be Batman is not an element of the Avengers. Here I have some information about just the different sets of values and everything. So natural numbers, integers. I'm not going to read through this, but this is just really useful information to come back to when you're going through sets and all about everything you need to know about sets, like intersection of sets, unions of sets, like what is a natural number, what is an integer, what's a rational number. So natural numbers, I'll just go through like the highlights. Natural numbers start at 1, 1, 2, 3, 4, 5, 6. I already kind of talked about the natural numbers. Integers include the whole number, so the whole numbers is 0. So the whole numbers start at 0 and go through positive infinity. But then the integers include the negative. So -1, -2, -3, -4, and then going out to here. And I have a whole video on the real number system breaking down all of these categories and defining them a little bit more. Rational numbers are just if you could write a number as an integer, that's supposed to be p over q. I don't know what happened with the right here. P over q is this. I'm not sure what happened with that. That's supposed to be p over q. Where p and q are integers and q is not equal to 0. So as long as you can write it as a fraction or a decimal, terminating or repeating, then that would be a rational number. Irrational is a number that cannot be expressed as p over q. I don't know why it says pq. So you can't write it as a fraction, like the number square root of 2 or the value of pi, like right here, pi. You can't write that as a fraction, so it would be irrational. Then real numbers is a set of natural numbers, integers, rational numbers, and irrational numbers. So it's giving you the quick just breakdown of those. If needed, I'll come back to those, but I don't want to spend 5 minutes talking about these systems. Number systems here. So computing the cardinal value of a set, finite or infinite. Cardinal value is the number of elements in the set. So the cardinal value tells you the number of elements in that set. So set A is a set of natural numbers less than 5. Let's look at what the set A actually is, and then we can determine its cardinal number. So natural numbers start at 1, right here, natural numbers start at 1, and then go through infinity. But we want this set of natural numbers less than 5, so let's use the roster method, just list these out. So that would be 1, 2, 3, 4. Not less than 5. It doesn't say equal to or less than 5, or it doesn't say that we can include 5. It says less than 5, so it has to be 1. Oops, 1, 2, 3, 4. So the way we notate the cardinal value of a set is we say n and then whatever the set is. So if I just call this like the set A, they call it. So n of A equals 4, because there are 4 elements in that set. Number 12, R is equal to Tim, Zach, Tom, and Brad. These are the members of Rage Against the Machine, if you're not familiar. There are 4 elements in this set, so I would say the cardinal value, n of R, is equal to 4. Set Z is the set of capital letters in the alphabet, A, B, C, D, all the way through Z. So that's 26 letters in the alphabet. So n of Z equals 26, because there are 26 letters in the alphabet. Next one, number 14. We have A equals the empty set. That's just the empty braces. So the empty set doesn't have any elements in it, so the cardinal value of the empty set is n of A is equal to 0. There are no elements in the empty set. 15, R is equal to P over Q, where P and Q are integers and Q is not equal to 0. These are the rational numbers that we're talking about. Going back to those definitions, rational numbers. This could be a lot of numbers. So I can't really define how many values are in there, because it could be like 1, 2, 3, 4, 5 all the way through. It could be 1/2, 2/3, 7 over 3, 15 over 11. Like it could be an infinite amount of terms. So the cardinal value, this is infinite. I can't define how many elements are in this set, so that's going to be infinite. So the rational numbers are infinite. Last topic is equal versus equivalent. So let's write down a couple definitions, a lot of definitions in this section. Equal, set A and set B contain the exact same elements. So set A and set B contain the exact same elements. Equivalent is the cardinal value is the same, but not the same elements. So equivalent means that the cardinal value is the same, so there's two elements in both of these sets, but they're not the same elements, but their cardinal values are the same, but not the same. But equal, set A and B are both the exact same elements, same everything. They're equal to one another. So one thing I want to write down here is equal is also equivalent. But equivalent, sorry, my pen kind of dragged there. Is not equal. So if a set is equal, it's also equivalent, but if it's equivalent, it's not necessarily equal. So those don't go both directions there. So equal is also equivalent, but equivalent is not equal. Number 16, we have the set 2, 4, 6, 8, 10. So the cardinal value of this set is E. So the cardinal value of E is we have 1, 2, 3, 4, 5. So 5 values in that set, elements. And then we have the starting lineup of the Chicago Bulls: Harper, Jordan, Pippen, Longley, and Rodman. That cardinal value is also 5, but it's not the same elements. The cardinal values are the same, but not the same elements. So these would be equivalent. Not equal, only equivalent. Equal would be 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Same exact elements that make it up. They might be mixed around, but it's the exact same elements. 17, 2, 4, 6, and set B is a set of even integers between 1 and 7. So we already have A listed out. Let's write out B as a roster method. I cannot make those braces. So the set of even integers between 2 and 7, so that'd be 2, 4, and 6. Look at that. 2, 4, 6, 2, 4, 6. Same. The cardinal values are the same, so the cardinal value of A is 3. Cardinal value of B is 3. These are equivalent. They're equal because they're the exact same elements, so I'm just going to say equal. Set Q. 2, 3, 5, 7, 11, 13, all the way through 89, 97. So those are prime numbers. Then set P is X. All the P is a set such as the X, such as all X values less than 100, and X is a prime number. So that would be the same exact thing. All the values less than 100, and X is a prime number. Prime numbers start at 2, 3, 5, 7, 11, and so on. So that would be equal. Don't have to necessarily write that P set out because we know what they are. Prime numbers less than 100, so that would be equal. Last one, A and B and A and C. So the cardinal values are both 2. I don't have these sets labeled. I was called A and called as B. So the cardinal value of A is 2. Cardinal value of B is 2. So cardinal values are the same, but the elements are different. Even though A and A are the same, one has B, one has C. So we can't call those equal. We'll call them equivalent. So this section was all about the basics to understanding what goes into a set, the properties of a set, and then we'll move on from there and expand on sets.